Hello everyone. In this lecture, we would learn a very important topic in pharmacology. This topic is essential to understand all the upcoming topics in pharmacology. It's one of the fundamentals. So let's get started. We would try to make it simple as much as possible. Alright? Okay. Here is a cell in our body. This cell, inside it and outside it, there is ions. Let's first look at what concentration every ion is found. For example, sodium is found at a concentration outside the cell more than inside the cell. So the concentration of sodium outside the cell is larger than its concentration inside the cell. Okay? Also, chloride ion is found more outside the cell, as well as calcium. So sodium, chloride, and calcium are found more outside the cell than inside the cell. Okay? But potassium, on the other side, is found more inside the cell. Okay? These ions move from outside the cell to outside the cell, or from inside the cell to outside, through pores or channels, and they move according to the concentration gradient. They move from high concentration to low concentration. So, for example, when sodium channels opens, sodium moves from outside the cell to inside the cell. And on the opposite side, potassium, when its channels open, it moves from inside the cell to outside the cell. Okay? Now let's have a look at this cell when it is in resting state, when there is no action in it. Okay? We agreed on that inside the cell and outside the cell there is ions. There is also proteins inside the cell. So the presence of these ions and these proteins inside and outside the cells makes it charged. There is charge inside the cell and outside the cell. But the question is, what charges are more dominant inside the cell and outside the cell? Inside the cell, negative charges are more dominant. That doesn't mean that there is only negatively charged inside the cell. There is potassium, which is positive, but the negative is more than the positive. So inside the cell is more negatively charged, okay? And on the opposite side, outside the cell is more positive than being negative, okay? Or than the inside the cell. So inside the cell is mostly negative and outside the cell is mostly positive. Okay, so there is difference between the electricity or the voltage between inside the cell and outside the cell. And when there is difference in electricity or voltage across two sides. We call that polarization. So our cell is polarized because inside the cell keeps the charge, or it keeps it more negative, and outside the cell is mostly positive. Okay, there is polarization, and this is the status of the cell in the resting state when there is no action. Okay, so now let's have a look at what happens in this cell which is in resting state, so there is an action. We will draw a graph between membrane potentials and time. Okay, we would measure the membrane potential, and we are measuring it inside the cell relative to outside the cell. And since we are measuring it inside the cell relative to outside the cell, we would start with membrane potential that is negative in its value. Okay, so at resting state, we would start with negative 70 millivolt, and we call that potential the resting potential. But when there is a stimulus to that cell, there is some leakage that occurs for sodium. Some sodium ions enters inside the cell, and sodium is positively charged. So we have a larger potential. This number, or this value, which is negative 70 millivolt at resting, it would be less negative. So we would find that membrane potential increases somehow because there is leakage for some small number of sodium channels. So here is the increase that occurs to the membrane potential. Okay, so the membrane potential becomes negative 55 millivolt. Okay, and at that level of negative 55 millivolt of membrane potential, there is something very interesting occurs. Many of sodium channels open. Many of sodium channel open. So that level, we call it threshold potential. When we reach or hit this threshold level, many sodium channel open. So a huge amount of sodium enters the cell. So we would found that membrane potential becomes like that. There is a fast increase in membrane potential because there are many sodium channels opened and large amount of sodium enters the cell, and our membrane potential becomes positive 35 millivolt. Our membrane potential now is positive, opposite to the resting state, which was negative, and it was negative 70 millivolt. Now our membrane potential is exactly the opposite. It is positive now. So the opposite of the polarization state occurred. So we call what happened depolarization. So depolarization is a state which is opposite to the state which was when the cell was in the resting state. Okay, and it occurred because of opening of sodium channels, which happened after our membrane reached the threshold level. So the stimulus occurred here. So leakage of some small amounts of sodium occurred. Okay, that made made us reach the threshold level. At this threshold level, negative 55 millivolt, huge amount of sodium channels opened. So huge amount of sodium channels entered the cell. So there is fast increase in membrane potential and it reached positive 35 millivolt. And this is called depolarization. Okay, so that happened because opening of sodium channels, and we call that sodium channels voltage gated sodium channels. Why they are called voltage gated? Because they opened, or its its gates were opened after the change in voltage. So these channels are controlled by voltage. When it is negative 55 millivolt, they open. Okay, until we reach positive 35 millivolt. These voltage-gated sodium channels at positive 35 millivolt, they close. So they open at negative 55 millivolt, and at 35 millivolt they close.